This is Algebra 1, Lesson 6.9, Systems of Inequality Word Problems. So we've done systems of equations, we've done system of inequalities, and now we're going to do some word problems with system of inequalities. So just like we did in equations, system of equations, they're going to give you enough information to write two equations, in this case two inequalities. So the first thing you want to do is decide what's going to be your x and what's going to be your y. It doesn't matter. You don't have to choose the same thing I do. It says you can work at most 20 hours next week. You need to earn at least, you can see your inequalities here, $92 to cover your weekly expenses. Your dog walking job pays $7.50 per hour, and your job as a car wash attendant pays $6 per hour. So there we have our x and y. Again, doesn't matter. I'm just going to choose that dog walking is my x. And this will be the number of hours that you worked as a dog walker. And the second one is your car washing attendant. Okay, our y. All right, so again, they're going to give you enough information to write two inequalities. The first thing is you can work at most, there it is, at most 20 hours. You know, remember, go back to that chart of inequalities. That means less than or equal to 20 hours, okay? So we're going to say the number of hours you work as a dog walker plus the number of hours you work as a car wash attendant has to be less than or it could be equal to 20 hours. There's our first one. Now it says you earn $7.50 walking dogs. So we walk $7.50 per the number of hours we walk the dogs, plus we got $6 an hour for working at the car wash, and we need to make at least, there it is, that keyword again, at least $92. That means we need to earn more than or equal to $92. There's our two inequalities. Let's go ahead and put them in slope-intercept form so we can graph them. I'm going to subtract x from each side. So I get y is less than or equal to negative x plus 20. We know there's really a 1 in front of there, and we put it over 1 for our slope. And the second one, we're going to move that 750 to the other side. We're going to subtract 750x from each side. So I get 6y is greater than or equal to negative 750x plus 92. Now we're going to divide everything by 6. And I'm going to use my calculator to simplify that fraction. And that gives me 5/4. Negative 5/4, that's not a bad slope. We can handle that. X plus and 92 divided by 6 gives us 15 1/3. We'll just estimate that on our graph. Okay, great. Now we decide on our scale. So I look at my two y-intercepts. I need to get up to 20 and I need to get up to 15 1/3. So I think I'm going to go by 2's. Okay, so let's go by 2's. So my first y-intercept is 20. So we're going to go, and we said that our y is car washing. This is car washing over here, and this is dog walking, the number of hours we're going to work. So I'm going to go by 2's, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Boom, right there. That's our y-intercept. And our slope is down 1 over 1, and it's okay. If they're by 2's, it's still the same thing, down 1 over 1. What does this represent? This represents the number of hours we're working either at the car wash or walking dogs. And it's an equal to sign. We're allowed to work up to 20 hours, so I'm going to make a solid line. And so you can work 20 hours at the car wash, but that means you're working 0 hours dog walking, or you can work 20 hours walking dogs. That means you work 0 hours at the car wash. And we want that to be less than, so we're going to shade down. All that works. Okay, now this one, we're starting at our y-intercept is 15 1/3, so we'll just estimate 2, 4, 6, 8, 10, 12, 14, so 15 1/3 somewhere in there. And our slope is down 5 over 4, so it's going to be 2, 4, 5 over 4 right here. Down 5, 2, 4, 5 over 2, 4, and down 5 all the way down to here over 4. And again, that line's going to be solid. And we need to earn more than that, more than $92 or greater. Okay, so you can see our solution is this section right here. What does that section represent? That represents the number of hours you could work at the car wash or walk a dog, and both of those would satisfy your two conditions. Let's try another one. This time, Marcia's buying plants and soil. So let's let X equal the number of plants. Again, doesn't matter. You could do it the other way. And Y is the number of bags of soil she's going to buy. Soil costs $4 per bag and plants cost $10 each. She wants to buy at least, there's our clue, at least 5 plants. And we said X is plants. So we said X has to be at least. So that means greater than or equal to 5 plants. That's our first inequality. And she can spend no more than, we know that means less than or equal to $100. So we're saying the number of plants she buys, which costs $10 each, plus the number of bags of soil, which they say costs $4 each, has to be no more than, so less than or equal to 100. Okay, so let's go ahead and graph that. First, let's put it in slope-intercept form. So I'm going to subtract 10x from each side. I'm going to divide everything by 4. So again, we get a fraction here. That's perfectly fine. That's our slope. And that's going to be, what, 25? Okay, so our y-intercept is 25. Let's go ahead and simplify that fraction so we can graph a little bit easier. So we're going to say less than or equal to, 2 goes in there, -5, 2x plus 25. Okay, so I need to get up to 25, and I need to get over to 5. So let's say we're going to go by, 5s, or graph by 5s. So 5, 10, 15, 20, 25, there it is. Okay, these are by 5s. Okay, and then from there we go down 5, which is 1 block, over 2. I'm going to go ahead and allow my x-axis to be by 1s because I only need to get up to 5 on my x-axis. So these are going to be by 1s. And remember what that x-axis represents the number of plants we're going to buy, and the y-axis represents the number of bags of soil that Marcia's going to buy. So I'm going down 5 over 2, 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 until she runs out of money there. Okay. All right. And that was, she wants to spend less than or equal to that, so we're going to shade down. Okay, the next one we're going to graph is x has to be greater than or equal to 5. So we go on our x-axis to positive 5. 1, 2, 3, 4, 5. And remember, this is going to be a vertical line. It's going to be solid. And she wants to buy at least 5 plants, so greater than 5. So we're going to shade to the right. And again, here's our solution where the two overlap. What does that represent? It represents the number of bags of soil and number of plants that Marcia can buy and stay within her $100. Okay, let's just set up this one real quick. Jason is buying wings and hot dogs. Okay, there you go, your X and Y, whichever one you want to do. X is number of wings, Y is hot dogs. Okay, 1 package of wings costs $8. 8 times the number of wings plus hot dogs are $5 per package of hot dogs, and must spend less than, okay? He can't spend $40, so we're not going to put an equal sign, $40, and he has to buy at least 4 pounds of hot dogs. There it is, 4 pounds at least. So that is greater than or equal to, we said hot dogs are Y. Number of bags of hot dogs or pounds of hot dogs has to be greater than or equal to at least 4 pounds. Okay, we'll put that in slope-intercept form. We'll graph this, and we'll see where the two intersect. Let's do that real quick. Let's put that in slope-intercept form, and we'll decide on our scale. So I'm going to subtract 8x from each side. So I get I get 5y. I get 5y is less than, I'm bringing this 8x to the other side, so -8x plus 40. I'm dividing everything by 5. Again, don't be worried about that fraction. That's our slope anyway. And what's that? Go in there 8 times. Okay. All right, so we're going to graph these. I think we can go by ones. It looks like I have intercepts of 8 and 4. That's not bad. So I'm going to start at the y-axis. 1, 2, 3, 4, 5, 6, 7, 8. There it is. What does y represent? Oops. 1, 2, 3, 4, 5, 6, 7, 8. What does y represent? The number of bags of hot dogs he's going to buy. Okay, and then we're going to go down 8 over 5. 1, 2, 3, 4, 5. There it is. It's going to be a dashed line. And we want that to be less than, so we're going to shade below it. And the last one, y, remember you go to your y-axis, which for us represents hot dogs. We go to positive 4, 1, 2, 3, 4. We're going to make this a solid line. And we want greater than. He has to buy at least 4 pounds of hot dogs. So we're going to shade up. And here we have it again. Here's our intersection. What does that represent? That represents the number of bags of hot dogs or wings that Jason's going to buy. Please try the practice problems. Let me know if you have any questions. Thank you.